Hi all, welcome to my course project assessment for Machine Learning Foundations for Product Management. The first project topic that we got was to build a model to predict the electrical energy output of a combined cycle power plant, which is actually a power plant using multiple combinations of gas turbines, steam turbines, and heat recovery. Our goal was to predict the electrical output energy, and we were given data set of around 9568 observations from the power plant itself. We had multiple data points or columns that were available to us, which are temperature, ambient pressure, relative humidity, and exhaust vacuum. We were also given the net hourly electrical energy output for all of those observations, which is essentially something that we're trying to predict as and create a model for. The first step for this was identifying the machine learning approach. As we have a labeled data set available to us, I decided to use supervised learning as we are predicting an output, which is a numerical value and a continuous value at that. So I used a regression technique and chose multiple regression because we have multiple input parameters here. For metrics, the outcome would be to predict the electrical energy output, the best efficient temperature and combination of um, parameter to for more electrical energy output, but the output metric that I've chosen, um, as I've chosen regression as the mean squared error metric, which we'll use to evaluate our model on. The second was looking at all of the features. As I said, we had 5 data points. Four of the data points are something that I used as a feature, which are temperature, exhaust vacuum, ambient pressure, and relative humidity. I tried to do a plot to help visualize better. In the y-axis, we have net hourly energy output, and x had all of these features. Next was to identify algorithm, which was multiple regression, which is essentially a very effective and first model for benchmark. Um, then the next step was preparing the data, which I used 80-10-10 method. Validation set is 10, test set 10, which we are using to predict the output for, and the training set was 80%. For models, I created 3 different models. For first, I started 3 random features to check the model efficiency using the validation data set. For second, I use all of the features, and the third one, basis all first and second, I identify what could be the better model and chose the third one. Ran for all of these, I started with validation set initially to determine which is going to be a better model value using the regression summary and the output that I got using the validation data set, which is R square, significance, and as well as a p-value for each feature. Then I finalized on the model, ran it through training set, and then used the equation derived from it to get the prediction. Now, going through the data set that we had, this was the data set we had, which had 4 different input features, and this was the output that we were supposed to predict. I divided that into testing, training, and validation data set. As I said, 10-10, 80-10-10. Then the first algorithm that I used the 3 parameters that were there. Um, and then ran it through data analysis and regression in an Excel to identify multiple values here. For multiple R and R square, we got 92, which is closer to 1. So that means that there is a correlation and we can predict the output. I checked the p-value for each of the parameters or features. I found out that ambient pressure has an extremely high p-value as compared to this, which is much more than 0.05 percentage. So that is something that is where that was something that I marked, and I decided that as an input to identify which model to choose. As you can see, the significance is 0, which is a good measure so that, all the feeds are having a correlation. Then it gives you the residual and the output as well to calculate the mean square error as well. What we also have are coefficients, which we can use to generate the the equation for linear regression, if that is something that you use. As you can see, I have used validation set here. For second model, I used all of the features and ran the same regression analysis, found the coefficient for each, tried to plot that. Again, in this, I observed that ambient pressure is 0.4, and which is relatively higher than others. That's why I decided, using not using this as a feature, and then create the third model which has only these three as an input. And this was again divided into three parts: the validation, training, and test data set. I ran through the same thing and kind of confirmed my belief, because the MSE that I got was very less as compared to the earlier one. I use the same to run it through the actual, test case that I have, and use the equation generated earlier using the coefficient that I had found to predict the values for each of these, calculated the error, the square of error, and the mean square error. As you can see, it is 20.15, which was the lowest of all. That was my approach to calculating the mean square error and my modeling approach. Thank you.